Okay, so remember how I said that rational numbers include numbers that can be written as fractions? Okay, and then remember how I said irrational numbers are not decimal numbers that repeat with a pattern. They're only numbers that go on and on without a pattern. So I need to show you how to write those numbers that go on with a pattern as a fraction, because we need to prove that those numbers that go on and on forever with a pattern are indeed rational. So let me give you an example. So we all know that 0.3 repeating is equivalent to 1/3. And how do we know that? We just kind of memorized that 0.3333 repeating is very, very close to 1/3 of a whole. What about numbers like 0.7 repeating? 0.7 repeating is not 1/7, because we know 0.7 repeating is larger than 0.3 repeating. And if we thought this was equal to 1/7, this fraction is smaller than that one. So that cannot be true. So I'm going to teach you guys how to write these repeating decimals as fractions, so we can say these are rational numbers, and this is how I know, is because they can be written as a fraction. So to do this, let's start by saying, okay, x is equal to 0.7 repeating. So if we know that x is equal to 0.7 repeating, what would 10x be equal to? Well, we would take this number right here and we'd multiply it by 10. And remember, when we multiply it by 10, we can simply move our decimal one spot to the right, okay? So 10x would be 7.7 repeating. Does that make sense? 1x is 0.7 repeating. 10x is 7.7 repeating. We just move the decimal once. Okay, so what I'm going to do is I'm going to write this in a different way. I'm going to say 10x is equal to 7.7 repeating, and I'm going to subtract this 1x from it because I want to get rid of that repeating 7. That makes it really confusing on how to write this as a fraction. So I'm going to subtract that 1x, which is equivalent to 0.7 repeating. So remember, as long as I subtract the same thing from both sides, or something equal to it, then that's okay. It'll keep this equal. So 10x minus 1x is equal to 9x. And 7.7 repeating minus 0.7 repeating would just give me 7. Okay. So if 9x is equal to 7, and I want to figure out what just x is equal to, I am going to divide by 9, and then I'm going to get x equals 7/9. Now, if we get our calculator to double check our work, and I type in 7 divided by 9, because that's what 7/9 means, 7 divided by 9, I get 0.777777 on and on repeating. The very last digit goes to an 8 because in our calculators it just automatically rounds. But 7/9 is how we would write 0.7 repeating as a fraction. And now I could say this is a rational number because look, it can be written as a fraction. Let's try another just single digit repeating like that, because I know this is kind of a weird concept. So let's do 0.4 repeating. Okay, so if it's only one digit like this that repeats, 0.4, we kind of just follow the same method. What would 10x be? What would this be if I multiplied it by 10? Move the decimal once, and that would be 4.4 repeating, okay? And my whole goal is I want to get rid of that 0.4 because it's really hard to write that as a fraction in the form that it's in. So I'm going to say, well, 10x equals 4.4 repeating, and I'm going to subtract 1x from that. And 1x is equivalent to 0.4 repeating. So I can subtract this from here and this from here, and they look different, but I know that they're equivalent to each other. So that won't mess up my equals. Okay, so 10x minus just this 1x would give me 9x. And then 4.4 repeating minus, 0.4 repeating would just give me 4. And then I'm going to go ahead and solve for x. Divided by 9, divided by 9, cancel, and then I would get x equals 4/9. And to double check my work, I'm going to plug that in my calculator. 4 divided by 9, enter, and I get 0.444444 repeating on and on forever. So now I can make my argument. This is a rational number because it can be written as a fraction, okay? So I'm going to attach a paper to this, and I only want you to do the ones that are just 1 digit long. You could attempt the other ones, but I'm going to make a video showing numbers that are longer than 1 digit repeating that I'll show after this one, okay? All right.